Here we're going to look at one where we're evaluating or we're calculating the logarithm. Log base 3 of 9. We want to figure out what is this equal to. I like to start out, if we don't know what it's equal to, we'll write it as equal to x just to get started. And then we're going to change it from this way of writing it, the log form, we'll convert it over into exponential form instead. So just like we did in the last few examples, to change it from log to exponential form, we just need to swap around these two things from one side to the other side. That will allow us to write it as 3 raised to the x power is equal to 9. And the question becomes, what needs to go there for x to make 3 to the power equal to 9? That would have to be the second power, right? 3 to the second power is equal to 9. So 2 is the answer to what needs to go for the letter x. We can write log base 3 of 9 is equal to 2. 2 is the exponent, in other words, raise 3 to the second power, we get 9. Here we're going to look at log base 4 of 1 over 16. And like the last one, I'm going to start by writing it as equal to x. And then I'm going to swap things around from one side to the other. I'm going to write it as 4 raised to the x power equals 1 over 16. And then the question becomes, how do we know what needs to go in the place of x to raise 4 to a power to get 1 over 16? Well, in this case, to put the number in the denominator, we need a negative power. If we raise 4 raised to the negative 2 power, that's the same as 1 over 4 raised to the positive 2 power. The negative exponent's going underneath into the denominator. So it would be 16 when raised 4 to the second power, 1 over 16 in this case. So the answer to what needs to go for x, the exponent, is negative 2. We write log base 4 of 1 over 16 is equal to negative 2.